The software upgrade will be written and rolled out in 3 months. I don't know how to do Dilbert's voice. He actually has a TV show.
Has that project of this complexity ever been completed by the estimated finish date?
No, we're confident we're going to be the first. Is that because you're doing anything differently from those who failed? No, we're doing exactly the same way as the people who failed.
You see what I'm getting at?
No. we're going to be on budget too. Snort.
And they're not going to change the targets when you turn it in for the first run.
Pretty much. So Kyle showed this to me earlier, and I tweeted it out as Einstein's insanity test. Doing the same thing over and over again, expecting a different result. This is, so what Kyle and Derek and I do is a technology called Data Virtualization. Not that difficult, I hope to explain. You know, you've got server virtualization companies like VMware and such. They'll take CPU and RAM resources and they'll give you a virtual machine a lot faster. But all those virtual machines, they need a full image of storage. They need full set of file systems, databases, app stacks, the whole thing. We virtualize storage. So this is for data virtualization. These are some of the companies that are using data virtualization, and they use that not just to save space, but really to kind of increase the pace at which they're able to do development. I mean, as we're going to mention later on, one of the biggest constraints to Agile development and continuous integration is the availability of environments in which you can work. So these folks achieve a 2x speed up in their, on average, in their applications. And there are a variety of different organizations, NASA for the government, McDonald's for retail, Costco, Facebook. You have to sit there and ask yourself, you know, what could I do with a 2x speed up on my application development and my testing? What would happen if my competitor had the 2x speed up and I didn't? So the upshot is, you know, what do these companies realize that maybe we haven't?
So what excites me about this is the DevOps movement is, as opposed to most people I meet, this is constantly over and over in the industry, is like, you know, hey, I've got a better way of doing something. Are you interested? And like, no, I'm busy. So are you too busy to innovate? So 2 weeks ago, I went to the Enterprise DevOps Summit, and I met a lot of companies: Barclays, Target, Macy's. Even the one that impressed me the most was the CIO of the Department of Human Services in the government. He's bringing Agile into the government. I'm like, that sounds impossible.
Yeah.
But he's doing it, and he's pretty excited about it. So I'm really happy to see people changing these old quagmires out there.
Something different from what we've been doing for decades.
So we talked about this a little at the beginning before we started. What is DevOps? I think the simplest definition is it's tools versus culture. In culture, what do we want? We want to bridge the silos mainly between development and ops. But we want to create empathy and collaboration and stop blaming or avoid blame. But it's going to take tools. One of the primary goals of tools is automating things, getting the human steps out of it, be able to measure, get feedback, what's working well, what's not. And then self-service, empowering developers to do things that doesn't have to ask the operations guys for. But sort of the meta DevOps, and I'm more into pragmatic, as I mentioned. I like to know what tools do and why they work and why they don't work. But the goal is something bigger. It's not just the tools and cultures. Look at what DevOps is bringing people, look at what people are doing, and go for that. So DevOps is basically optimizing the flow from dev to ops to production. But the real goal, the bottom goal, is we have companies. We want to improve the bottom line of the company. That's a real goal, and that's the thing that's important to keep in mind. Not just what tool is it or what Agile, Scrum, burn down methods people are using. So now I'm going to start talking about approaches to problems. So how many people have heard of the goal?
Read the goal?
How many people read the goal? Nobody's read it? It's a good read.
Yeah.
But we'll talk about it. But
listen to it on your headphones as you're going to sleep.
I don't have time to read anymore, but I'm listening to everything on Audible now. But the goal is basically a fictional story. There's characters who live through these life events, but the point of the goal is to talk about the theory of constraints. And so the theory of constraints is any improvement that's not made at the constraint is an illusion. Now, I don't know, when I first heard that, I thought that sounded obvious. But, and this was applied to factory floor automation.
Did you hear about the Phoenix project?
Yeah.
Okay, so
We'll get into that.
Coming up.
So, I mean, I'm a computer guy, you know, I'm like, computer programs are crazy, operations is crazy, this is factory floor automation. But if I had a factory and we have these orders coming in and I'm not able to produce the orders fast enough to satisfy my sales, and I'm the factory foreman, and I see these guys kicking back at some of the stations and they're not producing, I'm like, get to work. Everybody should be working 100%. And I'd be going around the factory making sure everybody's working really hard. Well, the theory of constraints, what's surprising is that's not a good thing to do. So say we're making pipes. We start from resin, raw material, and go out to shipping it. So the leak detection station is actually the bottleneck, the constraint, the slowest point in that factory floor. If we tune before the constraint, then I'm going to get a stockpile of stuff that I have to manage. It's going to take me extra energy to manage it, piling up before the constraint. Got to store it, inventory systems. If I tune after the constraint, I'm telling you guys work faster, they're starved. They don't have product to work on. So what we need to do is find that constraint and optimize that constraint. That's the only thing that's going to serve us. So that's factories. I thought, well, that makes sense. Factory floor, you're going from A to B. What about IT? IT is like herding cats, man. There's stuff coming in from 360 degrees. I'm like, could we actually apply that to IT? And that's what the Phoenix project comes in. It takes an IT group who has all these problems, company that's like losing on the stock market, their competitors winning, producing new features for their web pages that they couldn't do. And it applies the same theory of constraints to it. And it actually works. And so if you haven't read it, I highly recommend. The goal is probably more drier. This thing, if you read this, a lot of people read it. It works in IT, and like I couldn't read it because I was sweating. It was too real. I was like, so much like work, I couldn't read it.
They're both excellent novelizations. I mean, you've got, intrigue, politics, sex, everything like that. All that in with a textbook. It's kind of rare.
I missed the sex part.
Yeah, I don't remember the sex part.
I think it was on page. Work with me here.
So just to summarize the Phoenix project, basically one of the things he does is the main character goes through and talks to the different departments and finds out what are the goals of the department and what's the goal of the company, and so he can get his operation teams in alignment with what's actually going to help the company the best. And then once he has the goals defined, he goes through and collects metrics. What metrics will tell them whether they're on track or off track? With those metrics, he can use the metrics to identify where are the constraints in operations. Once we identify the constraints, we can set priorities. We want to attack those constraints first. And then using the metrics, we can see if we're on target or off target. We want to iterate fast so we can get closer and closer to being on target. Now, it's really cool in the book. He doesn't use the buzz terms in the industry. He doesn't say Agile. He doesn't say continuous integration. He doesn't say Kanban. I don't think he uses any of those terms. But he goes through the process of using them, which is better. That's what we really care about. So he does talk about continuous integration, using the cloud, Agile, Kanban, and Kata. And the author of the book, well, there's multiple authors, but the main author said IT is the factory floor of the century. So if the only thing that matters is tuning the constraint, well, what is the constraint in IT?
Spoiler alert.
So what is that constraint? And the author of the book, Gene Kim, said the top 5 constraints in IT from most important constraint to least important constraint are: first, building development environments and development environment setup. Second, building QA environments. And he says one of the most powerful things organizations can do is to enable development and testing to get environments they need when they need it. And a recent CIO magazine survey found that over 6% of projects are over budget and over schedule. Surprise, surprise. Of those over budget and over schedule, 85% of them were delayed because they were waiting for data and environments. And it's only getting worse. Gartner did a study and they predicted data doomsday. By 2017, they expect 1/3 of IT departments will go through a crisis where they can't handle their workload. So what's in this presentation? We'll talk about data being the constraint. Why is data the constraint? What are the impacts? Find a solution. how can we solve this problem? And then we'll look at use cases. What would happen when we have the solution? So first, data is a constraint. So moving data is hard, and the backbone of most applications is some sort of database. Probably the bigger the company is, the bigger those databases are. Actually providing copies of that data for development and QA, UAT, it's a lot of work. It takes storage and systems and personnel and time.
It's not just databases, it's app stacks, application stacks, file systems, etc. Just massive amounts of data, and every byte has to be moved.
Yeah. And interesting thing is, even if I had all the storage, all the systems in the world, it would still take me time, and all the personnel. I still take me time to make copies of this stuff. So here's the typical architecture we see. We have some production system, usually hooked up to a database. The database is usually the biggest chunk of data. And we have to, first of all, we have to back it up. So we have some guys, DBA guys, storage guy backing this thing up. Then we have reporting, so people are going to run business analysis, business intelligence reports on it. And then we come into where we are, which is development. And the development's going to take a lot of copies. We need development copies for the development team, probably multiple copies for QA, ideally multiple copies for QA, UAT, and integration.
How many environments do you have, dev environments, non-production environments that are supporting your production at your shop? Seriously. Okay, I asked that question
The last
once.
one I worked at had 32.
Yeah, that's a right number, and that indicates that you've started down the road on Agile and DevOps. But for a shop that is totally up against the wall, I mean, a dozen is not unusual, or even a half a dozen. Some of them, really bottlenecked. I was a couple of months ago during the summer. I asked that question, and someone pops up his hand and says 110. Everyone turned and looked at him. He's like, "Hey, man, we believe in this stuff. That's how many we have. So we have to have it. Everyone has their own environment to work with, and that's the optimal way to do this. Is not to share environments, not to only refresh on occasion."
So they believe in continuous integration.
That's pretty much what he's saying. Yeah.
And then to refresh all these copies, it stresses infrastructure. You got to copy all this data across the networks. One military branch we talked to, they said basically at 5 p.m. on Friday, you got to get out of the office because it's going to be the network's clogged up all weekend. I think better be good. Nobody better attack us on the
exactly.
weekend.
Everyone's going to have to sign up. Not to attack the U.S.
And so this data floods infrastructure. Interesting report from the Wall Street Trade Association. 92% of the business cost in when we do stock trading, arbitrage, is all data. That's a lot of the cost of the business. Now in brick and mortar, average IT spending is like 5% of the company's budget. But of that, about half of it's on data. And that data is getting bigger. So this is where it's hitting the bottom line of the company. Remember the goal, our whole goal really, as people in a company, is how do we improve the bottom line of the company? So this data constraint's hitting in 4 areas. So IT capital resources, personnel, application development, and then the business. So of course, to have these copies, it's going to take hardware. It's going to take storage, network, data center floor space, cooling, conducting a lot of revenue. And there's never enough environments. And one of the classic stories is here in the state of Colorado, the legislature signed off on 100 projects. But at the time we started working with them, they only had enough infrastructure for 3 of those projects. We get a bottleneck on projects. And then the operations, this takes thousands of hours of people time. Talking to companies, I come from a DBA background because I talk to DBAs. At the Fortune 2000 companies, it's typically thousands of hours a year of DBA work just making copies. I'm not talking about maintaining schema or performance or anything else that DBA does, just copying the data. And then that goes across all these other groups. And also, if we want to do something like data center or modernization or migration, moving all that data is going to run in typically tens of millions of dollars.
I was working at the state of Colorado recently on their SAP cloning methods. And at the moment, they have a process that they've documented in Excel that has about 150 steps. 20 of those steps involve copying data, whether it's making a safety backup or copying it or moving it, just 20 of those steps. And if you look at each one of those 150 steps by duration, those 20 steps are the ones that stand tall in terms of a bar graph showing the amount of time. It's a long, complicated process. You have to protect yourself against any missteps so that you can fall back to a previous step without having to go all the way back to step one. 150 steps to clone an environment, and that's just the average. What's that? Yeah. All along the way.
It's definitely a good step, yeah.
But right now it's Excel.
How many people are using Puppet and Chef? Everybody? No? Are you guys using any automation tools like that?
We're working on getting that. But we kind of hit that level where we're starting to go, we got to start automating things.
Right.
Or whether we knew it, imagine we
Right.
started to realize it.
Right. I think that's one of the big things about DevOps. It takes executive buy-in, really.
Yeah.
At some
Because
point.
it's an investment. And if you ask somebody about those 150 steps, they'll say, well, each one of them is scripted. It's automated. Now we're into orchestration. It's not just scripting.
So we talked about capital resources, operational resources, and now it's hitting application development because we can't get the environments we need. And that's going to impact us in some ways I'll talk about more later. But it's going to be high cost of QA, inefficient QA, sharing environments between developers because they can't get enough, slowing down how fast they can code, trying to get workarounds like using subsets of data, which ends up running into bugs, and just waiting for environments and slowing down development in general. And then finally, it's hitting the business's bottom line because if the business can't get this data, then the business is going to make decisions that are not well-founded. For example, if I'm like Walmart and like the new Batman toy sells out on the East Coast in the morning, I want to know that for the other stores across the nation and be able to revision them quickly. So older the data, the less intelligence our businesses have. And then what I think is the most surprising is this problem that we've been stepping through here, most companies I talk to aren't aware of it. And if they are aware of it, they're like, well, that's just life. I mean, data's big, takes a lot to copy it, we just have to live with it.
We've been doing this for years.
It's always worked. We also have the best IT department in the nation, and there could be nothing better. But they don't necessarily know what's going on. If I'm a developer and I ask first of all, I'm not going to ask for an environment. But the reason is because I've already done it at some point in my career and I know what the response is, I'm not going to get it. So if I have some specialized project or a bug I need to analyze that I saw in production, I can't get an environment to look at it. If I'm a business analyst and I don't already have a copy, I'm not going to get a new copy if it doesn't already exist. So the company higher up doesn't know what's needed by the company because they don't hear about it. I like to go into companies and ask for metrics. So the one I love the most is like, we'll go into, there are solutions to this, right? So what if you could get that database in 2 minutes? Point and click in a web browser. And the guy's like CIOs, like, we already do that. So I'm like, really? Okay, if I ask a developer, if he asked for a copy of the environment, how long would it take to get it? What would he say? That's the real question. Odds are it's going to be a no. And if he does get a yes, it's usually going to be measured in the weeks. And then even in development or mostly QA, how old is the data? I mean, usually if I have a big crowd, I'll ask them everybody to stand up and be like, everybody whose data is like a week or newer, sit down. And we'll keep going. We'll reach into multi-years of data age because it doesn't get refreshed. And then how much storage is all this copying taking up? And then other parts of the business, how old is data for business analysts? Is it 1 day old, 1 week old? How old is it? If you have an audit, Sarbanes-Oxley or Dodd-Frank, CCAR, can you actually get a copy of the data when they're asking for it? And if you can, how long would it take to get it? So, what are some of the problems this causes? I hit on these a little bit, but it's going to cause the bottlenecks. We don't have enough environments. It's going to slow down getting projects started. We have to wait to get these environments. It's going to slow down the developers because they're going to share copies so they can't code as fast as they want. It's going to cause bugs in production. We can't test as much as we want. And QA in general is going to be slow and expensive. So we've talked about this already. If I have a new project coming into the company, we have a limited amount of available resources. It's going to definitely hit a bottleneck. If I have a new project, I've got these, and I got the developers lined up, they're ready to go, but I've got to build all the environments for them. The typical time I hear starting a brand new important project is about 3 weeks to get environment set up. And a lot of people are like upper level management. It's like, oh, well, they're working on stuff. Well, I'm sure they are, but I mean, you might be watching kitten videos on YouTube. I don't know how productive they're going to be. Once we get them up and running, and I've seen this at big companies like eBay, we'll have a bunch of developers working on one copy of the environment, especially one back-end database. Like, well, what if somebody wants to make a schema change or add metadata? What do they do? Well, like, oh, well, yeah, they have to have a code review. Okay, how long does that take? This is eBay, 1 to 2 weeks. I'm like, if I'm a developer and you're telling me I got to wait 1 to 2 weeks to get that schema change to write the code that I need to write, I'm going to kill my motivation. And then as we mentioned, if all these people are sharing one resource, how often is it going to get refreshed? It's going to be pretty rare. It's going to be tough to get everybody off. It takes a few days to refresh it. Nobody wants to be off for that long. It just doesn't happen. So what do people do? A lot of people go to a subset. So instead of either maybe a synthetic schema where it's not the real production data, or they take the production data and try to slice it up into smaller bits. Well, what happens when developers work on these subsets or synthetic schemas and then QAs on it? We hit what's called production wall. We see new data that we've never seen before, never tested against. We see data quantities we've never tested against. And then what happens to the operation guys? Developers like it worked for me. It must be an operations problem. And then one of the biggest problems I see is QA. One of the customers I talked to, of their QA cycles, they spent 96% of the QA cycle building the environment, running destructive QA tests, and they rebuild the QA environment. And this is a cycle that just runs over and over again. And because it takes a while to build an environment, if a bug gets into the code, it's longer before we find it. And the longer it takes to find it, the more dependent code gets written on top of it, the more work I have to do to fix that bug. Ideally, we want to find the bug as soon as we can. And so this probably should be preaching to the choir here. I imagine preaching to the choir, but if DevOps possibly even with these data problems, but I think the allure is very intriguing. So on the top, I've got a guy who's like on a mammoth wave trying to surf. He's actually on a windsurf. Actually, I met this guy in Hawaii. Yeah.
Oh, you took that picture?
I didn't take the picture, but I met the guy. But if I have one release a year, it's going to be a big mammoth thing, and I haven't been trained that well, I'm going to get clobbered. This happens over and over again. And my idea of Agile and continuous integration is we're doing integration all the time. There's small integrations, and also we build up like the muscle and ability of the dexterity because we've been doing it all the time.
It's only a small fallback.
Yeah. So water versus Agile. The idea is, in my experience, I mean, I used to work at Oracle and work with the Waterfall shop. How many times has Oracle ever met a release date they said they're going to do? So we set up these big massive specs. We work for a few years at Oracle, and we find out, whoa, we're way off path, but we've got to release it soon, try to get back on path, try to fix all the bugs, and we screw up somehow. I mean, we have huge bugs, or we're missing features that we want. The idea of Agile, I worked at an Agile company. We had 2-week scrums, we had burn down rate, and I and the group I was in on my project, we never missed a date. It was pretty cool for me. So we might go off course, we'd have a runnable version, like we just run it in-house, and then we get back on path, keep these small cycles going. And if we're doing continuous integration, we're finding the bugs as we go. If we're doing Waterfall, we'll start testing with Agile and continuous integration, start testing right away, start finding bugs right away, and we keep pretty much on top of it. At Oracle, well, there wouldn't be much code to test in the beginning. Once we get near release dates, then we start running some serious testing. We find we get overwhelmed by the number of bugs we find. Now, this might not apply to everybody, but if I'm running small Agile, and I have usable code early on, I can start, especially a shop like Google or Facebook or Flickr, they can start monetizing that functionality right away. If I'm in Waterfall, I can't monetize it to the very end until it's actually done. And then as far as release goes, in continuous integration, I'm testing all the time. So my whatever release costs I have stays pretty constant. in Waterfall, if I want to release it once at the very end, the longer that project goes on, the more work I have, the harder and more expensive it's going to be to actually do that release. But when it comes to these big data, where I only have a limited number of environments, and it takes so long to create environments, is continuous integration where we're testing maybe multiple times a day? Is that even possible? If creating one copy feels like that, well, now we'll talk about what's the solution. If I'm creating these copies over and over again, in general, especially, I mean, my experiences with databases, in general, across all those copies, across the different environments, 99% of the blocks, the data blocks, are actually identical, the same block. And each of these environments changes little bits and pieces here and there, but not that much. So, somebody had the bright idea, well, maybe there's another way to approach this. Maybe we could share all the duplicate blocks. When these copies, these different environments make changes, those changes stay private to that environment. Now, how do we do that? There's a lot of technologies that have been out there, actually, what's called file system snapshotting. Now, it's actually been out there 20 years, but read something interesting recently. It was 30 years after the Wright brothers flew that actual commercial airline started. It took 30 years before people started really profiting off air flight. So this stuff's been out there for 20 years, but people really haven't profited that much. But if you have EMC, you can make snapshots. EMC is so limited on symmetrics, only 16. If you have NetApp, you can take 255, getting better. If you have ZFS, you're unlimited, so it's pretty cool, and plus it's open source. DXSS is the file system we use. We sort of originally had ZFS, and we modified it for data copying purposes. On the right, I said some of the new flash storage, they come with this, snapshotting technologies. But the snapshot itself is just what I call the fuel. What we want is basically something like continuous integration. We want the DevOps of cloning. So why isn't the snapshot the car? There's two problems. One's technical and one's bureaucratic. So first is the bureaucratic one. I've talked to shops that use NetApp. They take these file system snapshots and they make their data environments cloned off the snapshots. And the first shop I went into, I was like all excited. I was like, how long does it take you to create an environment? And the guy, I was thinking like, maybe 20 minutes, 4 minutes, I don't know, something fast. And the guy's like, 4 days. And why does it take 4 days? The guy's like, well, you have to like submit a work request, and that goes to somebody who accepts it or declines it. If it's accepted, it goes to the DBA. DBA talks to the system admin talks to the storage admin. And as it goes through all these people, it ends up taking several days. Also, it took me a little while to wrap my head around why does it even take several days, because each step should be pretty quick. And this is a chart from Phoenix Project. But the idea is, something that took 1 hour when the guy's like 50% idle, it gets up to 90% idle, might take him a day. It gets up to like 99% idle, might take him 9 days. Now, big guy's busy, so the DBA or the storage admin. Well, in-house IT operations, how busy are they generally? Really pretty more work than they can actually do. So it sort of makes sense that these data cloning environments take a long time, even with cool technology. Now that was a bureaucratic problem. The technical problem is, if I have some source production system running and it's got its data that I want to snapshot, if this is on like EMC or NetApp or something, it's pretty easy to take a snapshot. And once I have a snapshot, it's not that hard to mount that over, say, Fibre Channel NFS onto a target machine, a developer's machine. And then developers start working on their snapshot. But the problem here is that developer is going to be sharing the same spinning disks as production. I mean, how many people are going to allow that? The whole point of making copies is to get away from production, because production is where we're making our revenue. That thing goes down, we lose tons of money per minute.
The other thing would be if target B, this team that's working here, after all this is created, they need a new copy. There's only one snapshot that they can base off of. Right? They created one snapshot, now they're creating clones from that. If they want something that's newer, more recent copy, they have to take another snapshot that's a full copy.
So the solution to that would be, what we actually want to do is have our production system and somehow copy that data over here to what we call maybe the development system, and there we take our snapshots. But there's a couple of hurdles there. One, if we just take an original snapshot, just like Tim was saying, Well, say that's yesterday. Well, say today somebody needs a copy of today's database. Well, then I have to bring up a whole new copy, so that defeats the whole purpose. So we need some way, ideally want some way to keep the base version in sync with the source version. And here's what the car would be, ideally. I have my source system over here. I want some automated way to first copy it over to this development system that has snapshots on it. And then I want to keep copying all the changes, so I don't have to take a whole full copy again. And ideally, I'd like a time window. So I have maybe a couple of days here that I can spin clones up within that window and purge data outside of that window. Well, so this has to have snapshots on it, so I can take these thin clones. It would be nice if it could do compression. It would be nice if it not only stored data on disk, but also in cache, just like a file. And then, sort of the really important part is self-service provisioning. I want some way where somebody can just hit a button and say, I want this production environment on this development box. So I need a way to provision here. If these I need to mount over NFS or fiber channel. And if it's a database, I need to be able to mount and recover and rename that database. And if I'm going to give that kind of power out, I'm going to need some self-serve. I'm going to need login, roles, and security. So how would I create this? So you have, if you want to tackle this, and I think it's worth tackling, there's a number of ways to tackle it. So here's the 3 steps as I see them along my line. Source system has to link to some store the snapshots, and then I want some way to self-service copies of that environment. So EMC has snapshots. They have a thing called SRDF, which will replicate just the changes from one file to another. You're still missing the provisioning part. Same thing with NetApp. NetApp I can make snapshots, and then they'll actually propagate the changes from production to development. Snapshot manager for Oracle, snapshot manager for SQL Server. Oracle has a thing called EM12C, where they will provision databases, but they require that you get NetApp or ZFS. And then they actually don't have any way to sync these two, but you can put it together yourself using something like DataGuard. It's the way of syncing one database in one system to storage on another system. There's a company called Activio that's a solution that will do all this full stack. They're hardware-based. And then Delphix is software-based, does the full stack. So those are ways you could approach it. Now, ideally, we want more than just those snapshots. We want to do what we call data supply chain. I want a way to make data flow through the system, flow from production to development to QA to UAT, and maybe back to production. And I'm going to want things like masking, because there's a lot of data in production I don't want a developer to see. And I want security. Who has access to all these copies we're making? Who has access to it? It'd be nice to have chain security, chain of custody. Definitely want self-service so people can do it themselves. Pick the DBA, storage element out of the equation. If I'm going to have developers, I'm going to want things like data versioning. So we have source control for source. How about data control for data? And then for auditing, I want things like live archive, where I can go to a previous point in time quickly. And ultimately, what I want to do is I want a continuous integration. I want some developers to be able to, I want to spin off a bunch of copies of the production environment for developers. I'd like to get every developer's own copy, ideally, so they can work as fast as they want. And then I'm going to want to be able to branch those quickly to QA. Maybe I do that once a day for continuous integration, run tests on these QA copies. And because these are sharing storage, they're low in resources, I can spin up a bunch of copies. And then we just keep this iteration going. And another thing cool is, maybe I've talked to a lot of shops that have multiple versions of their application being worked on at the same time. Well, we can all be sharing basically most of the data from production. So I can have version 2.6 of my application using the same data as version 2.7 and keep it separate. So I don't know how Activio works, but I can tell you how Delphix works. And I think we're the only 2 companies that do the full stack. But basically, Delphix is software. If it's on a USB, it installs on any x86 hardware. It supports full automation, like point and click in a web browser for these databases. DB2 is, we have customers trying to use it, but you have to do some wrapper and scripts around it. And we'll also do any data, file system binary, info. Once Delphix is installed on the x86, you give it some storage. the cool thing is it doesn't matter what storage is. It could be JBODs, because we'll map our own file system onto it that does the snapshots. And the cool thing about that too is it allows us to use any flash system. I don't know who's going to win the flash market. So it might be Nimble one day and Pure the next, or Extreme.io from EMC the next. So once we have the software installed, runs as a VM under VMware, or runs in AWS, and some storage assigned, then we point it to a source system. If there's databases on there, we'll find the databases. You can say, I want to link to a database. When I link, we do a one-time full copy, never do it again. And that copy is compressed by 1/3 onto the storage. And then probably the coolest part, though, is from that point onwards and forever, we cut just the changes from that source. So whatever data gets changed here, we pull in the change data blocks and build up this time window. And we can spin up a clone anywhere from within that time window. I don't know how technical we want to go tonight. So there's a little bit on the file system. Is this getting too technical? Do you want to go into file system or?
It's how copy on write file system.
Okay. So this is the interior structure of the file system that gets mapped on the disks that are given. So these gray blocks are data blocks, and these are metadata blocks. So instead of being forced to be continuously laid out on disk, they can be laid out anywhere. And the metadata will tell us where the blocks are that make up the file. So if this was the initial link to a database, and these are the blocks that make up that database, and then we pull in we found some new blocks that are changed. So B got changed, and C got changed. We bring in those blocks, and we put them in the file system. So when we hook them in, no blocks ever get overwritten. This is the cool part. So this metadata block that points to the data blocks, it doesn't get overwritten. We allocate a new one that points to the new blocks. And it goes all the way up to URL, the top block, the URL block. Now this is a really cool thing is, if I give you this root block of the file system, you point to the past. If I give you this block, you point to the current. So that I can give you a point-in-time version of the file system within, sub-second. So if I want to purge, like so I purge that old version so we can have a time limit, I just get rid of the blocks that were associated with that previous root block. So now, what if I want to give you a copy? I just copy that root block and I give it to you. And immediately you've got a pointer to the file system at a point in time. This is a new copy. I'll get a second copy instantaneously. And what if I try to change something? So say this guy tries to change some blocks.
Sorry.
So he changes the block I. Well, that doesn't interfere with any of the other copies of the file system. His pointer to that block I will change, and his pointer. So then I can give you copies of the file system, give them instantaneously. You can modify your file system. It doesn't interfere with anybody else's file system. So what does this do to our development QA environments? So before, if I had these 3 copies, dev, QA, UAT, or something, and they're all full physical copies, being stored on some NAS or SAN. In the virtual world, those 3 copies become what we call Data Virtualization appliance. Behind the scenes, there's only 1 copy, and we're all sharing it. Anybody that modifies the block, that block is kept private to that copy. So this is our what we typically see in the industry architecture. Very complex and heavy, takes a lot of people. It goes from this to this, where I have the source production being compressed, kept here, and a time window. I can spin up a copy anywhere within this time window. Not only do we keep block changes for the source, we keep block changes for any of these what we call virtual copies that we make. So how does this change our life? So 3 areas: development. One we care about the most is development QA, but also impacts production, support, and business. So for development, we'll have unlimited copies, basically, full size, and you can give self-service to developers. So now it's easy. So I've got the source database and things like database virtualization appliance, and then I can spin off these copies basically a couple minutes. I'll promise no storage. So before, where we had a bunch of developers sharing 1 copy of the database, and if they wanted to make a schema change, So VDB is what we're calling like a virtual database, a virtual data.
Also called V files.
So instead of people wanting, if they want to change schema, waiting a week for a code review, now I can give them all their own copy that can work as fast as they want. And these copies, they're for all intents and purposes, they're full-size copies. So those bugs that happen because of subsets don't want we catch them before they get to production.
It's not 3.2 here. Yeah.
And then one of the cool parts is self-service. And one of the goals of DevOps is automating and giving self-service. So I can give, instead of a developer submitting a work request asking like, goes to his boss, it goes to the DBA, system admin, storage admin, he can just hit a button in a web browser. Now, depending on what side of the fence you're on, that might strike joy in your heart or strike fear in your heart. Most DBAs I talk to are like, oh my God, you can't do that, you don't do that, they would go crazy. But I mean, the idea is like, get them out of your hair. Like, these things don't take up any storage, and also I can limit what they can do. I can limit how many copies they can make. I can limit, if they do modify data that is stored, so I can limit, and they could take up a lot of storage, but I can limit how much storage. So you can only change this much data. And then I can have a chain of custody, so I can see who had access to what.
And it's all a progression. I mean, somebody could have written this system, this software earlier, but the thing is that it's all about spending authority. Because if a developer, if creating a new environment requires the spending authority of a vice president or the director of IT, then you're certainly not going to have self-service truly be something that the developer just goes in and points and clicks. But when provisioning the environment, spinning up a virtual server costs nothing, spinning up virtual data costs nothing, then finally it is actually okay for people to actually use the self-service application that you built for them.
And so I think the impact is even bigger for QA. So for QA, again, fast environments, parallel environments, be able to roll back environments and to do destructive testing over and over and A/B. So, and one of the big problems I hear about is like we mentioned earlier, is like it takes a long time to build a QA environment. If I have a development team, they finish maybe they're nightly. I ideally want continuous integration, but more typically they finish a sprint and want a QA. Then I have to build a copy of whatever data environment development is using and give it to QA, and it takes a long time. Well, now with data virtualization, so developers have branched off from the timeline in the data virtualization appliance. They're working on it. They've made some changes. I just branch. It only takes a few minutes. I branch, and then QA has a copy. I don't have to wait at all. And because they don't take very many resources, I can get a bunch in parallel. I'm not stuck with one single QA resource. And then if I'm running destructive test, I can spin off a QA database. Maybe I do some setup. Maybe I do masking. Maybe I walk some accounts or do different type of setup. And then I run my destructive tests. I don't have to go rebuild it. I can refresh right back to wherever I finish my setup and run the test over again.
Same thing with app stack.
And then A/B testing. I spend a lot of my time with performance, and I'm always want to try this test. I want to try that test. And, maybe I want to I think the database in production would be faster without that index, but I can't go into production. I'm really not interested in going to production and dropping it, but I don't have a copy I can play on. Well, now I do. So now I can add an index, drop an index, make some modifications, and compare the performance between different versions easily. And then now we have data version control. So if we produce version 2.1 of the application and basically shut it down, now we're working on 2.2, but then a bug comes along 2.1 and it's urgent, and I need to go back to 2.1 environment and fix that bug. Typically before, it'd be a lot of work to create that environment. Well, now I have this time flow, and I can bookmark it, so I have these dots so you can say that's a point on my key. I can go back to that point, spin up an environment in a few minutes, and have the developer start working on my bug fix for 2.1. So that was all development QA, but this, and that's probably the stuff I'm interested in the most, but this stuff carries on to other parts of the company. So for production support, it helps with backups, recovery, forensics, migration, and consolidation. So one of the, I think is, again, I come from a DBA background, so backups are a big pain in my neck and scary. They take up a lot of space, they're critical, and I don't get to test them very often. But with data virtualization, say I had a 9 terabyte database. So this is the size of the database. This is a 30-day range. In the Oracle world, the recommended backup practice is first take a full backup, and then over the day, start to implement all the changes during the day. And the next weekend, over the weekend, when you have some time, low usage, put the full backup again. So if I kept a month of backups with their standard practice, I'm taking quite a bit of space. With data virtualization and compression, that 9 terabyte database would be 3 terabytes. And then this is 1 terabyte of change per day. That 1 terabyte of change would only be a third of a terabyte of change. So it's not until I hit like week 3.5 where I'm actually at the size of the original database. And then I can spin up a copy anywhere within that time range. So it's much more efficient, and it's easy. It only takes a few minutes to spin up a copy. So this has happened at, I don't know how many customers we work with, but somebody on production does something wrong. Like classic case here locally, Comcast, DBA dropped movie title table. So they have 26 million streaming movie viewers. They couldn't rent movies because there's no movie title. They have a failover for, well, changes go directly into failover immediately. We want to keep things sync as much as possible. So the other option is go to backup, which takes about 8 hours to recreate from backup. Well, they hadn't even bought our product yet, but they bought it in 2 days earlier. They already had linked it. It took them a few minutes to spin up a copy before, so we have this time delay. Spin up a copy before they dropped the movie title table, spun it up, and then exported it and imported it back into production. And this is something I didn't think about until I started working with customers, but they were like, one of the cool things we think is cool with data virtualization is we'll have a bug in production that only lasts for a little while. It seems to be related to the data sets. But we don't want to develop it on production. And by the time it comes on the next day, the effort it would take to build production as it was during that problem time is just not worth the effort. And it's like, so we just live with the bug. But with data virtualization, since it only takes a few minutes to spin up a copy, next day when I come in the office, I can go back to whenever that problem is happening in production, spin up a copy, and give it to the developer, and they can start working on that bug. And then this is sort of the other side of the coin, backup. What about developer environments? Oftentimes, I say 50-50 development environments don't get backed up. Like, I was just in development environment, you're not in tier 1, tier 1 gets backed up, and you're in tier 3 and it's not backed up. Well, who's more likely to screw something up? Production DBA or a developer doesn't know the database very often. The developer. And I'm like, well, DBA, I dropped this table, I didn't mean to drop that one, I dropped this other one, can you get back to where I was? And usually the answer is no. Well, now, if in the virtual database, it's sort of a fringe benefit, they get pulled into the client flow as well. So if something goes wrong on developer's database, then I can spin a copy up before that problem happened, throw away the old copy, and I get all the changes that were in that copy up until the point where it wasn't wrong. So this is getting some bigger concepts, but what about data center migration? If we want to move from one data center to another data center, this S stands for like the source productions, like C for phones. It's going to be a lot of work to copy all that from one data center to another. In the virtual world, if you had some other way to virtualize it, this would be the source, these would be the virtual copies. If they're all in the data virtualization appliance, basically this could be smaller than the actual source database because it's all compressed. And if anybody's sharing that compressed version, I'm basically moving maybe less than one size, one copy of the original database. So it's here, I can move 5 or 12 or 30 or however many copies you have. So it makes data center consolidation or migration a lot easier. And then consolidation. If I have a bunch of databases, and this happens out there, like if I get a database, and someone gives me a database, and maybe I've used it for the project, I don't let it go. I might need it, and I'll never get it back. So we have all these data environments sprawled out over the IT department, and people are holding on to them, but not being used that much. But we're getting charged, like by Oracle, we're getting charged by core count. What if I could move those all together? Well, in the virtual data world, it's easy to move things together. Since all the data is on the database virtualization appliance, I can shut them down on one target, start them up on another target, consolidate all the databases easily on the one target, and get charged less. And then a final area it helps is business intelligence. So ETL jobs gives us access to simple data, competence testing, federated data, and audit. So a lot of times we run ETL jobs at night, where we want to extract things from the load. We want to run it when there's low usage on the production site. But then as data sets grow, a lot of times these ETLs outgrow their time, their not any batch job windows and fail. When we go to a global economy, there might not be any batch windows except maybe a weekend. And when I'm running these ETLs, often I'm stressing the infrastructure, pulling all this data across. But in business, what if I miss a nightly batch job? If I'm doing it daily, the next day's data is going to be a couple of days old. If I'm doing it weekly and I miss a weekend batch job, I'm maybe 2 weeks old. Well, data virtualization, I don't have to touch the production database. I just go to the database virtualization appliance. I can spin up a copy of production as it was a couple minutes ago. So basically gives me 24/7 access to running ETLs. I no longer have a time limit. And also, I'm just going to change it. So, and then one of the cool things is, depending on your perspective, developers have been asking us for ages, like, I want access to data as it was at certain points in time. If I ran this query yesterday, what data would it give me? What would it give me the day before? Well, databases have never really given that kind of support, at least not full-fledged support. Well, with virtual data, I can spin up copies every day for the last month, and then run those queries on those copies and get temporary data. And I don't know if you've ever had one like this. If you had to change like a big reporting job, but I'm not quite sure if that report change I made was correct or not, how do I QA that? Well, one thing I can do is I can go run that report the way in the day before data and compare it to the previous report. Did it change? Does that give me the correct results? And I can go back maybe 30 days and compare it to previous 30 days reports. And it doesn't prove my report change is correct, but at least it gives me a sense of confidence. It's confidence testing. And I think this is the final area. A lot of times, our application depends on multiple databases, and it's called Federated. So I have an application that uses multiple databases, and when I want to put that into development, I want to get a copy of each of those databases at the exact same point in time, which can be really hard. But in the virtual world, I can link to one source at 1 week, I can link to another source another week. It doesn't have to be the same week. Once they're both linked into the database virtualization appliance, I can spin up copies down to the second and have them both at the same point in time. So one example of this was with Informatica. They had a project where they wanted to consolidate 6 databases. So an application that used 6 different databases. Each database had a different customer information in it. Each database was run by a different DBA team. And they projected 12 months to do this, mainly because it was so hard synchronizing all the different teams to get the data at the exact same point in time. But I went to database virtualization, and they were able to cut that in half. They did it in 6 months. So the CIO, who was Tony Young, he said, I felt like a hero. He said, I brought the project in half the time, brought in more revenue, invested that revenue in innovation. And he actually won an award from the Quintana Research Institute for that project. Oh, yeah, final thing. And auditing. This time flow, depending on what requirements are, could be, by default, in our world, it's 30 days, but it could be 3 years if you want it to go longer. And I can bookmark certain important points in time. So for auditing, this will be really important, especially like in the world of financials. If I'm upgrading financials, I may have no way to go back to that previous version and supply auditors. But with this, I can just bookmark it. I can get back to that point in time in a few minutes. So just to summarize, so we go to data virtualization. It allows us to improve application development and QA. Also, it supports production support and also improves the business. And we've worked with a bunch of Fortune 500 companies. By going to data virtualization, we've seen them double their application development output. So other things that we've seen faster financial closes. One interesting thing is on Facebook, before the IPO, they're taking 21 days to do their financial close. They couldn't IPO with 21-day financial close. They had to get it down to a couple of days. They brought in data virtualization. But one of the reasons they had the problem is they had so many different revenue sources and they run so fast. They had to consolidate into a central general ledger, and they kept getting accounting discrepancies. They needed copies of these different databases. They needed to be able to change things on them and run reports and be sure they coordinated. And using data virtualization, being able to have all these copies allowed them to go from 21 days down to 2 days. But also faster business intelligence structures, surgical copy, like pulling data, putting it back in production, get back to production, and even faster projects. So it's quotes. This is the same thing. I see this running hand in hand with Agile and Devops. If you look at some of Gene Kim's presentations, he's done research on how much improvement he's seen in shops with DevOps. These are some of the customers we talked to with data virtualization, where projects, New York Life is a project from 12 months to 6 months. Presbyterian Health, their project from 50 days and down to 23. State of California, so I can't imagine working without it. So it's the sort of moral of the story is like instead of being shackled down by this enormous bureaucracy and heavy infrastructure, put a jetpack on the development teams. So what we've seen is data is the constraint. This is what we saw with Gene Kim and the Phoenix project. This new report a couple of reports came out last week. Devops consultancy said the number one problem they've seen is getting environments. The number one problem environments is supplying data to sustainability. The solution is to virtualize the data. And the results we've seen are half the time for projects, higher quality, and the bottom line what we want to do is increase the revenue for our companies.
Yeah.
Any questions on this?
It's kind of a fire hose thing.
They said people are coming in at 7, so it's like.
I think you're going. They were supposed to come here and.
Are you serious?
For tomorrow, so I don't think they're going to.
Oh, we could have gone slower.
Yeah, that's nice. Yeah,
So, what kind of performance measurements have you seen in the compression that performance requirements for meeting and processing?
Do you mean like what's impact on like I/O latency?
Yeah.
In our particular architecture, is like that particular thing has no impact on I/O latency.
It has a beneficial impact. I mean, you think about it. It's the old trade-off between CPU and I/O. Compression takes up CPU, but it reduces the size, the number of blocks you're going to be accessing, makes all the blocks denser, so you're doing less I/O. It's a very good trade-off. We have had folks asking us to turn off the compression so they could test it without, and it's not a good thing. They say, well, space is not an issue. We're going to take it without the compression, and they don't get any benefit from that. They have to less dense data inside the appliance, and they end up spending more I/O.
One of the cool things I think, this doesn't apply to the other data virtualization, but for our particular virtualization, we share not only on the disk but in the memory. So if I have like 10 clones working off the same data set on our storage, then it's also not only is it shared on disk, but it's in memory. So if I have say I have 128 gigs of data that I want to share, once that's loaded in memory by one of the clones, all the clones benefit from that cache. So it's sort of like super.
And that's the opposite side of an availability issue. Everyone will say, wait a minute, I've got this one appliance that's feeding 20, 30 development environments. What if that one appliance goes down? 20 or 30 development environments go down. But that just makes now that appliance, needs production quality.
Are they coming?
Okay, it just needs production quality
We've got food also. They're coming.
data protection.
For those of you
Yeah, we
who-
could bribe them with food. Maybe. So like everything else in computing, all that better caching, because everything is more compact and reused by so many different environments. It has a reverse side as well.
It's all right.
Yeah.
You want to come in?
Before we go, I want to thank you all for signing in. Just remember, would you like to put the number before going in? We have the
Yeah.
shoes and, of course, the project or it's given away.
Some kind of